What are vector quantities? Now, there are two types of physical quantities. There are the scalar quantities and the vector quantities. Now, let's look at the scalar quantities. These have magnitude only. And when you say magnitude, it means size. And we look at vector quantities, they have both magnitude and direction. Alright, so that is the main difference between the scalar quantity and the vector quantity. The scalar quantity has only size or magnitude, while the vector quantity, it has magnitude, yes, but it also has direction. We have a few examples of scalar and vector quantities. Here, time is an example of a scalar quantity. Now, when it comes to time, let me do some finger pointing here, or at least try. I can try to point my finger and say time had moved in that direction. But the thing is, it wouldn't make sense, because you cannot point in that direction or that direction or in that direction or whatever direction you want to point in. You cannot point in any of these directions and say time had moved, and that is the direction that time had moved. Time went that way or that other way, moved up or down or left or right or whatever direction you want. So it is a scalar quantity. Distance, scalar quantity. You do not ascribe a direction, you do not place a direction when you're talking about just distance. Speed, whether in meters per second or kilometers per hour, you don't say what direction it has traveled. Right? So mass density, volume, length, speed. I already spoke of speed. Distance and length, same thing. Alright? But when it comes to vector quantities, examples include weight, displacement, velocity, force, acceleration, momentum. These are vector quantities. Now, when you talk about something like weight, weight is a force, you know. So here, weight and force, they have something in common. It's just that the weight is the force of an object that an object exerts in attracting another object. For example, the earth is attracting you to it, and you call that the gravity. Alright? So, in that case, you have the earth, which is spherical. Let us say that this is the earth. It's supposed to be spherical. And this is you. And the earth is pulling you towards its center. Well, of course, you are also pulling the earth towards you. But of course, most of the force is being pulled by the earth, pulling you towards the center. That's how you are able to stand up. And if you jump, you are attracted back towards the earth. And even though I draw you up here, there's someone else on the other side of the earth, seem to be upside down. But as far as they're concerned, you are the one who is upside down. Right? If you're out in space looking at the earth. So the earth is also attracting that other person towards its center. Right? And when they point down, it's the same direction that you would point up. When you point down, it's the same direction that they would point up. Right? This is your down, but it's also their up. So in that case, the weight is the force that the earth or any other object, if you go in space and go on the moon or another planet, would be pulling another object towards it. For example, you, the force with which the earth pulls you towards it. And you can tell the not only the magnitude, if you use a scale, like a bathroom scale, but you can also tell the direction of weight. So it is a vector quantity. Force is a vector quantity. Alright? Generally, a vector quantity. You have displacement. Well, displacement is associated with distance, and you're talking about distance in a specific direction. You specify the direction, and that turns distance into the vector quantity displacement. Alright? Now, if you study physics, you know that mass is the amount of matter that you pack, that is packed in an object. The greater the mass, the greater the weight, if of course the object is on the same planet, for example Earth, at the same distance from the center, for example you and an object beside you. So you might have a mass of iron that are smaller than you but have more weight. For example, you're in a gym, there's a pack of dumbbells packed in a corner, not as big as you, but have more weight because they have more mass. Now, mass is just the amount of matter in the object, but weight is the force of gravity on those objects. As for mass, you cannot point and say mass is acting that way. But the weight now, you can point downwards at your feet and say my weight is acting towards the floor, right? Because you can feel the force between your feet and the floor, assuming of course that you're standing instead of lying down. Now, volume is of course the amount of space that is taken up, and you cannot point in a certain direction and say the volume is acting that way. So volume is scalar. Now, length, you do not have a specific direction assigned to it, but when you're talking about a direction, length and displacement. Displacement is the length in a specific direction. Just like what I said earlier, displacement is distance in a specific direction. Or you can say a specified direction. Alright? Now, velocity is speed in a specified direction. Acceleration is the rate of change of velocity. So if it is velocity that is changing and velocity is already a vector, then acceleration is also a vector. Acceleration, talking about at one point, you're going at 5 kilometers per hour, and then a second or a few seconds later, you're going at 20 kilometers per hour. Then a few seconds later, 30 kilometers per hour. So you're changing velocity, and you're going in a specified direction. And momentum is another example of a vector quantity, because it is momentum. For those who like the physics or are doing physics, it is the mass multiplied by the velocity. Alright? So you might have a very small car moving at 30 kilometers per hour, but you have a truck laden with sand moving at only 15 kilometers per hour. Now that truck has greater momentum than the car, because the truck is much heavier. It has a lot more mass and is much harder to stop than the car. It also takes a lot more energy to move from rest up to that 15 kilometers per hour than the amount of energy it would take the car to move from rest up to 30 kilometers per hour. Right? It's also much harder to stop that truck from 15 kilometers to rest. Even though it's slower, it's moving slower than the car that's moving at 30 kilometers per hour. It can stop much quicker. So that's one of the reasons why the truck driver should not drive too close behind smaller, lighter vehicles. The smaller and lighter vehicle can stop very quickly, but the truck has a harder time stopping, and it will take a longer time to stop, and it will hit the back of the smaller vehicle in a very, very quick emergency stop. The truck cannot stop as quickly as the car. Now, as we said earlier, the vector quantities have both magnitude and direction. Scalar quantities have only magnitude. That's the main difference between the scalar quantity and the vector quantity. We'll continue examining specifically vector quantity, which we will specialize in from now in further videos. So I will see you then.